Hello, welcome back to another one of these streams. Today we're going to be going through straight lines and circles. So looking at all the things that we need to know about straight lines, and then also the types of questions we could be asked about circles, and going through some straightforward ones as well as some challenging ones towards the end. So if this is a topic that you need to revise, it's one that people do find a bit challenging usually, which is why I decided that I wanted to go through this today. So hopefully this is going to be useful. And like I said, if you find it a bit of a challenging topic, then this will be hopefully very useful. So stick around. We're going to get started with just some starter questions, just on a mixture of topics. These are from Maths Genie, the mini tests, which again are a great resource to use. So if you haven't used them already, it might be a good place to go and have a look, or just a good thing to do if you've got 20 minutes, half an hour to work on something in maths. It's got a mixture of topics on there, and it's got them split up as well by grades. So yes, I would recommend it. It's on the recommended websites. It's a great resource from there. There's where they've got 45-minute papers as well, which are very useful. So I will give us a few minutes to have a look at these questions, have a think. It's also useful while you're looking at these to think about which topics they are, because that will help you to basically connect the dots in your brain, thinking, right, well, it's on this topic, what do I know about this topic, what can I use? And if you can't figure out where to start, just thinking about, well, actually, it's on this topic, what do I know about that topic, that will help you to try and figure out what the question will need you to do, probably before you've even fully read the question. Okay, so I'll give people a few minutes to join and a few minutes to have a think about those questions there. Welcome to the people that have joined as well. It's good to see you. I know it's early, but yeah, it's good to see people this morning. We have got less than a week to the non-calculator paper, and the topic we're doing today could be a non-calculator on the non-calculator paper. It could be on the calculator paper as well. I mean, really, they could put any topic on a non-calculator paper as well. So, obviously, I personally, the best practice I believe you can do is by doing the past papers, because you get exposure to the way they ask the questions. And so, if you haven't done many of those yet, that's what I would spend this next week, just really going to town with, just absolutely doing all the past papers you can do, because that will give you an exam technique. It will allow you to look at the mark scheme, what they give marks for, what they don't, as well as getting a feel for the topics that will be on there, and just generally practicing how to do the test. I mean, if you want to pass a test, the best thing you can do is to practice the test. If you want to be good at football, the best thing you can do is practice football. It seems an obvious thing, if you want to be good at something, the best thing you can do is practice it. Okay, so obviously the skills on there, and you can practice those skills, but really the best way to I'm only making football analogies here because I like football. The best way to get better at playing football is to play football matches. The best way to get better at these tests is to practice these tests. Okay. Right, so I'll just go through some of these are more obvious than others, but go through the topics. So this is a transformation question. The next one, we've got a speed, we've got a distance, and we've got a time, so speed, distance, time question. And then we've got builders, building something, building a wall. So that's going to be a proportion question, usually. And then this question here, triangles are mathematically similar, so that's a similarity question. Okay. Right, so I will start going through some of these questions and the layout, and again what the marks are for. Any questions at any point, type in the chat and let me know. And if there's any problems, anything, say the counter's not counting down or anything like that, again, please let me know. Because while I'm doing all this, it's difficult to see exactly what's happening. Okay, describe fully the single transformation that maps trapezium P onto trapezium Q. Well, it's not trapezium, is it? It's triangle, so I'm not sure why it says that. Anyway, somebody's obviously written this question, and obviously either not drawn the right shape or written the wrong word, one of the two. So triangle P onto triangle Q. So we're going from P to Q. It's important to know which way you're going, because otherwise we'll get the vector completely the wrong way round. And one thing to look out for is if they put something like A and B in the questions, say these are that's A, that's B. Usually it's A to B, so your natural instinct is to do A to B, but just make sure, just double check that it does say A to B and not B to A. Okay. Now it says describe the single transformation, so we've got to say which transformation it is. It's translation, so we've got translation and we've got by the vector. Now we're going from P to Q, so just look at a corresponding corner. I'm going to go bottom left to bottom left. Now that's 1, 2, 3, 4 down, and 1, 2, 3 left. So 3 left is going to be -3 in my vector, and 4 down is going to be -4. So with these vectors, if you're going left, it's going to be negative, and it's always x on the top, y on the bottom. So if you're going left, that's your x direction. And if you're going left, it's going to be negative because your numbers are decreasing. And if you're going right, it's going to be positive because your numbers are increasing. Now, if you're going down vertically, or if you're going vertically up or down, that's your y coordinate that's changing. And so that's on the bottom. It basically goes in the order of the alphabet, x and y. And again, if y is going down, that's, you know, the number's decreasing, so it's like minus, if you think of it that way. Or if you go up, it's like adding, so that would be positive. Okay, and that's all we need. We just need translation by the vector. There's no centre with translations, so we don't need a third bullet point. Okay, so translation by the vector, -3, -4. Okay, next question. A car travels at an average speed of 65 miles per hour for 2 hours and 40 minutes. Now my first thought here, with the speed, distance, time question, is to make sure all my units are consistent, so then I can start manipulating and working out things. So 2 hours, 40 minutes. Well, that's 2 hours, 2 points. Now that's 40 out of 60, which is 4/6, which is 2/3. So that's going to be 2.666 reoccurring. So it might be better leaving that as a fraction. So in total that would be 2 2/3. Or if we leave it as a top-heavy fraction, because that would be easier for timesing and dividing. I mean, we could use our calculators, but again, we'd need to type in the fraction, and we can't really type in. Well, I can't on my calculator, I don't believe, and some calculators won't be able to do this, type in the recurring part. Some can. I think the 83 GT and the 85 GT, the black models, usually I think they're black anyway. 2 2/3, 2 times 3 is 6, add the 2 is 8, so that's 8/3 in hours. Okay, and we've got 65 miles. Work out the distance travelled by the car. Well, speed equals, now how do I remember this? Well, in Europe the speed is kilometres per hour, and it's written like this. Now that is a distance divided by a time. Alternatively, you can use this triangle. Once you've got this set up, instead of having to work out and rearrange this to get the distance, we can do speed and then distance divided by, so that's on the bottom, time. And then the way this works, if I want distance, I cover up the D for distance, and then I'm just left with speed times time, and that will work it out. Alternatively, times both sides here by time, and you get speed times time is equal to distance. Okay, so we've got to times the speed by the time. So 65 times by the time, which is 8/3, which is, again, not going to give us a particularly nice number, but yeah, I don't think it will anyway. Just the, well, actually, no, I'm not going to do this. I'm going to do this without the calculator. I'll do 65 divided by 3. 65 divided by 3. 3 goes into 6 twice. 3 into 5 doesn't go, well, it goes in once, remainder 2, decimal point, carry my 2, decimal point here. 3 into 20 goes 6 times, again, remainder 2, and now I've got repeating decimal, so it's going to be 21.66666, or 21 and 2/3. Okay, so we've got 21 and 2/3 times by 8. 21 and 2/3 times 8, which is the same as 21 times 3 is 63 up to 65 over 3 times 8. Hasn't really helped me now, I've just got to swap the numerators here. I've got to do 65 times by 8 and then divide that by 3. Okay, 65 times 8. 5 times 8 is 40, 8 times 6, 48, add the 4, 52, 520 divided by 3, which I think I can do. So let's do it over here. 520 divided by 3. I would hope for this question it would be a calculator question, but it's a good idea that I'm going through these methods here for you so you can get a reminder of them. 3 into 5 goes once, remainder 2. 3 into 22 goes 7 times, remainder 1. It's not going to be a nice number, is it? 3 into 10 goes 3 times, remainder 1. And we're going to get 173.3 reoccurring, because I'm just going to keep getting remainders of 1s here. Just check that on the calculator. So 65 times by 8 over 3. 520 over 3, which is 173.3 reoccurring, and I'll just double check this as well. So 8 over 3 is 2.6 recurring. If I take away the 2 for 2 hours, times that by 60, I do get you 40 minutes. Yeah, so that's definitely right. So our answer was 173 miles to one decimal place is going to be 173. Now that's 0.33333, so it's going to be 0.3. And that would be, what would our units be? Well, miles, because that's miles per hour. So miles. Okay. Next question, it takes 5 builders 4 days to build a wall. Okay, so the way I would lay this kind of proportion question out is 5 builders, and that takes them 4 days to build this wall. Work out how many days it would take 2 builders to build the same wall. So we need 2 builders. Now I've left a gap there because I'm going to go down to 1 builder and then up to 2 builders, because I can't go from 5 to 2 by timesing or dividing in one go unless I did it with a fraction. Okay, so I'm going to go down to 1 builder like I said first and see how many days it would take them. Now we need to think, actually, would this be direct or inverse proportion? Now, if I had less builders, would they be able to build it quicker or slower? Now, the logical thing is, if you've got fewer people, it's going to take them a longer time to build something because they're not going to be able to do as much. So, actually, as one decreases, as the builders decreases, the time is going to go up. So this is going to be inverse proportion. Okay, as one decreases, the other increases. So if I divide by 5 on this side, I need to times by 5 on this side. 4 times 5. So 1 builder would take 20 days. Because you'd have to do all the work of the other builders. Okay, and then going, so times by 2. On this side I've got to divide by 2. If it's inverse proportion, you do the inverse operations. So if I divide on one side, I've got to times on the other. Inverse proportion, inverse operations. 20 divided by 2 is 10 days. Super, so that's how long it would take, 10 days. You can also do that with the formula or the equation for inverse proportion, and that is y is equal to k over x. Okay, where it could be 5 builders, so that could be y could be the number of builders and x could be the number of days. Now you would work out k, you times both sides by x, you get y times x is equal to k. K is your constant of proportionality, and I remember this is the equation for inverse proportion because it's the multiplicative inverse basically, and what that means is if I do x times by 1 over x, I get 1. So this is what's called the multiplicative, because when you multiply them, you get 1, the inverse, okay, the inverse of x. You don't have to know that, that's just a bit of extra information. Okay, so y times x, and if we did 5 times 4, plug our numbers in, 5 times 4, we get 20, so our constant of proportionality is 20, so if we then did, y was my builders, so how many days would it take 2 builders, so 2 is equal to 20 divided by something. Now you can rearrange this, but I'll just use it to show that the answer is right. 20 divided by 10 gives you 2. Okay, if you rearrange it, you'll get x is equal to 20 divided by 2, which gives you 10. Okay, but if it's with people or things, and you just want to find out, not the equation, but you want to find out, how, in this case, how many days it would take 2 builders, then just do it with this method is what I'd recommend. Okay, triangles are mathematically similar. Now you need to know what that word means. That word means basically that they're exactly the same shape, just one's been enlarged by some scale factor. So if I times one side by this number, this scale factor, and I times another side by this scale factor, I will get this similar shape. So all the sides have been times by the same thing. So all we need to do is look for corresponding sides and find the scale factor. So if I do 7.8 divided by 2.6, I'll get the scale factor, which is 3. So that's times 3, so that's got to be times 3. So then we do 2.2 times 3 is going to give us 6.6. Okay. Right, so that's the start questions done. I'm going to move on now to having a look at straight lines. Now before I do that, actually straight lines and circles, I just want to go through very quickly the things we need to know and remember about straight lines. There's quite a lot, so I'll make sure I remember everything. Basically, straight lines. If it's a straight line, it will always take the form of y equals mx plus c. Okay? Now m, the number before your x, it can be negative. That's your gradient. Okay, in other words, okay, how steep the line is. Okay, so that number tells you how steep the line is. The bigger that number is, the steeper your line is going to be. The smaller it is, the less steep, the shallower your line will be. And if it's negative, that basically means the line isn't going up, it's going to go downhill. Okay. Now C, that's the y-intercept. Okay, what does that mean? Well, that means where the line goes through your y-axis. Okay. So, if your line goes through the y-axis, that's the vertical one, at the number 3, this will say plus 3. This is the most useful way, in most circumstances, of having an equation of a line, because it tells you two important things, two key things about the line. This, the gradient, how steep it is, and it also tells you where it crosses the y-axis. Now, how do you calculate the gradient? So, you need to do, basically, change in y divided by change in x. And there's a formula for this. So y2 take y1 over x2 take x1. So that's your y coordinate, take away the other y coordinate, and your x coordinate, take away the other x coordinate. And that is for 2 points, x1, y1. Okay, so that's your first coordinate, which is what the 1 stands for, and then x2, y2. Okay, your second coordinate, which is what the 2 stand for. Okay, so that's how you can calculate the gradient. Now, essentially, the gradient also means, and if you've got the line in front of you, for every unit you go, so say you're on the line, so I've got a straight line here. For every unit I go right, how many do I go up or down? So if I go right 1 unit, how many do I go up? Now I haven't got an axis here, but if I go right 1 unit, and I have to go up 3 units, so 3 numbers to get back to the line, not necessarily squares, because it could be 2 squares for 1 unit, 1 number difference. If I go right 1 unit, up 3, the gradient's 3. If I was to go right 1 unit and down 5, the gradient would be negative 5 if you go down. So it's basically, if I go, right 1 unit, how many do I go up or down to get back to the line? That's a quick way of working it out if you've got the line in front of you. Okay, now the y-intercept, how do you work that out? So you work that out through substituting in your points. So substitute in coordinates. The one good thing about being left-handed is I can check my spelling before you can see it. So substitute in your coordinates, that's how you can work this out. And this, if it isn't in this format, rearrange it into this format. Now there's another straight line format which, if you don't know, you will, if you do A level, you will learn at A level, and they're shown it more at A level, I believe, students, but actually can be really useful. Now this other format, it's useful if you've got the gradient, so if you know gradient and have a coordinate and it says what's the equation of the line, you can use this one. So this is y, so you just write y, you don't substitute in for that, you just write y, minus y1 is equal to, so that is going to be an actual number, y1, you're going to substitute in for that, m is your gradient, you substitute that in, and then brackets x, don't change that, keep that as an x, minus x1. Again, that's from this coordinate. Okay. If you know gradient, have a coordinate, and I'll just put below that x1, y1. So gradient is m, and have a coordinate x1, y1, use this. Okay, and you don't need to rearrange that. So once you just plugged your numbers in, so e.g. m equals 5, and x1, y1 is 2, 3. Okay, equation of the line would then be y minus 3 is equal to 5, brackets x, take away my x coordinate, which is 2. Okay, now if I expand that, I add the 3 to the other side, I will get an equation in this format, but the good thing about this is you don't need to rearrange it. You can just substitute your numbers in, and that reduces the chances of when you substitute in coordinates to get your plus c, getting that plus c wrong. So I would recommend, making sure that if you can, you know this as well, because that can be very useful. Okay, reduce the chances of making errors. Okay, I think I've covered pretty much everything there, but actually there's the midpoints we need to do as well, so I should box this off. The midpoint's fairly straightforward. So if you want the midpoint of a line, okay, actually, I'll say you can't really do the midpoint of a line because lines go on forever, but if we midpoint of two coordinates, e.g. x1, y1 and x2, y2, so again you've got your two coordinates, you add your x coordinates together, and you divide it by 2. Basically what you're doing, you're working out the mean of your x values and your y values, and that's halfway in between them. Okay, so the midpoint would be x1 add x2 over 2, and y1 add y2 over 2. You work out the midpoints, or the averages, the mean. The mean, you add your numbers together, you divide by how many numbers you've got, so add two numbers together, divided by 2. So e.g., if we had 1, 5 and 3, 7, the midpoint would be 1 add 3 and half it, and then 5 add 7 and half it. So that would give me 1 add 3 is 4, divided by 2 is 2. 5 add 7 is 12, divided by 2 is 6. So that would be the midpoint. Okay, that's all straight lines. What I do need to do is go through the equations also for circles. So, we are going to do some questions on this. Just want to make sure we know everything first of all, before I start talking about it all. So a circle. So equation of a circle. And this is something people don't tend to remember as much, is because we don't really use it as much. X minus a squared plus y minus b squared is equal to the radius squared. Okay, where AB is the centre of the circle and R is the radius. Okay, e.g. x minus 3 squared plus y minus 4 squared is equal to 25 is a circle with centre 3, 4 and radius. Now you have to square root the 25 because it's equal to radius squared, so radius 5. Okay? Super, so that's all really you need to know about circles, and actually at GCSE we shouldn't have. I'm not au fait with all of the exam boards, AQA, OCR and things like that, so I don't believe it will say minus A or minus B. I don't believe it'll have that bit. I think we only need to know at GCSE x squared plus y squared is equal to r squared. So in that case, the centre for us will always be 0, 0. Okay, as far as I'm aware. I could be wrong, but I only know really for my exam board, the one that I've recently been doing at Excel. For Excel, they will only give you x squared plus y squared equals radius squared. Okay. Okay, and the radius would be whatever is equal to square rooted. Okay, and we will also get the tangents to a circle. And before we get on to that, a tangent to a circle is a straight line which just touches the outside of the circle. Okay, so that would be a tangent to my not very well drawn circle. It's not bad, but it's not the best. That's what a tangent is, and then a tangent would be perpendicular, if you know your circle theorems, to the radius. Okay, so perpendicular means your gradients are the negative reciprocal. And we'll get to a question like that later. Okay, gradients are negative reciprocal. And the negative reciprocal, what that means is if you times your gradients together, so gradient 1 times by gradient 2, you need to get negative 1. And that's how you show that gradients are perpendicular. You need to basically do this with your numbers. So 2 times negative a half gives you negative 1. You need to write that down to show something, or 2 lines are perpendicular, if you get a question like that. Okay, right, enough talking and explaining about all of that. I'm going to start now going through some questions. So, first one, a straight line has equation y equals 3x minus 2. So that's told me the gradient is 3, so it's increasing, it's going uphill, and it goes through the y-axis at negative 2. Write down the gradient of the line, it's 3. Write down the coordinates, so it wants both here. Don't get caught out by that. The point where the line crosses the y-axis. If it crosses the y-axis, then your x is going to be 0, and we've just got a height, so it's going to be 0 minus 2. It's going to be crossing down here, and it's going positive, so it's going to be something like this. Okay, well that's minus 2. Okay, super. Line A passes through the points 2, 1 and 5, 10. Find the equation of the line parallel to A that passes through 2, 5. If it's parallel, that means it's going in the same direction. So it's got to have the same gradient. Okay. The only thing that will then change is the y-intercept. So we're going to work out the gradient. So m is equal to 10 take away 1. So y value take away y value over x value take away x value. 5 take 2. So 10 take 1 is 9, 5 take 2 is 3, 9 divided by 3 is 3. So it's got to have that gradient, so we know it's y is equal to 3x plus c plus something. We've got to work that something out. Now we substitute, because it goes through this point, these values in. So 5 is equal to 3 times 2 plus something. 5 is equal to 6 plus c. Take 6 away from both sides, and you get that c is equal to -1. Excuse me. So then if we plug that back in up here, we get y is equal to 3x minus 1. That's the equation of our straight line. Be careful there to substitute that point in and not one of these two, because then it will go wrong. Okay, next question. Line A passes through the points 1, 5 and 5, 7. Find the equation of the line perpendicular. And this is what I was talking about before. Perpendicular, gradients are negative reciprocal. Okay, so again we've got to work out the gradient. So m is going to be, well, this gradient here. So I'm going to have a different m in a second, different gradient. Y value, 7 take away 5, over 5 take away 1. Now you've got to make sure you take them away in the same order. So if I do this coordinate, take away this coordinate, I've got to do 7 take 5, 5 take 1. Now actually it doesn't matter if you take them away the other way around. If I did 5 take 7 divided by 1 take 5, you get the same answer, because it will be negative on top and negative on bottom. That will cancel out, and so you'll end up with the same gradient, a positive one. 7 take 5 is 2, over 5 take 1 is 4, so we get 2 divided by 4, which is the same as a half. Now, the negative reciprocal, if you've got a fraction, the reciprocal is essentially just flipping it, and then you make it negative. So, we've got y equals, so here, for this bit, we've got y equals, flip it, you get 2 over 1, so 2 divided by 1, which is 2, and then you want the negative of that, so negative 2x plus c. Has to go through negative 1 and 7, so substitute the 7 in for y. 7 is equal to negative 2 times by negative 1 plus c. Now negative 2 times negative 1, it gives me 2, so 7 is 2 plus c, so what do you add to 2 to get 7? So c is equal to 5. And the equation of our line, plug that c back in up here, y is equal to negative 2x plus 5. Okay. Next question says, describe fully the graph which has this equation. Now I've just gone through circles, so this should be pretty obvious, hopefully. Now it's x squared and y squared, which means the centre, it says describe fully the graph, so it's going to be circle. It wants you to say circle. The graph basically means what's the line that's been drawn, you know, what kind of shape is it, what kind of graph is it. It's a circle we've got to get the centre 0, 0. If it's x squared and y squared, the centre is always 0, 0. If it's not, it's minus 3, then it would be 3. If it's minus 4, then it'd be 4. Centre 0, 0, and radius square root of the 9, 3. That's all we need. So we said it's a circle, said the centre, said the radius. Super. Moving on. Now again, there are some multiple choice questions. I believe these are for AQA. Usually, I think AQA might be. I don't know about OCR. EdXL definitely don't have multiple choice questions. I know AQA do. I'm pretty sure from the questions I've seen that OCR don't have any multiple choice questions. And this is exactly the same question, but it's multiple choice. Well, it's exactly the same equation, I should say. The equation of a circle is x squared plus y squared is 9. So centre is 0, 0, radius is 3. Okay, work out the length of the diameter. Well, the radius is 3, be careful because it's asking about the diameter. The diameter is double your radius, so that would be 6. Again, down here, the equation of a circle is x squared plus y squared, so centre 0, 0 equals 11, so your radius would be square root of 11 because it's equal to r squared. So radius is root 11, work out the length of the diameter again, so it's double that, so it's going to be 2 root 11. Okay, because 2 times by root 11 is 2 root 11, not root 22. Next question. P is the point negative 1, 1 is a point on the circle, centre O and radius R. Work out the value of the radius. Now the radius goes from the centre, so it goes from here to any point on the circumference. So I'm going to go to this point. Now we need to work out the length of the line. Okay, this is something actually I didn't cover before, which is one of the things there's so many things to do with straight lines. It's one of the things I didn't go through before, but I'll go through it now. So what we've got, if I draw these dashed lines, if I have a vertical line going straight up from the x-axis, that has gone, because it's negative 1 on the x, so that has to be negative 1, and this has to be a height of 1. So it's gone left 1, so that length there is 1, and it's gone up 1, so that length there is 1. Now using Pythagoras, because we've got a right angle triangle, we do 1 squared, add 1 squared, and then square root it will give us the hypotenuse. So 1 squared is 1, add 1 squared, which is also 1, gives us root 2. And that's then got to be the length of this line, which is the radius. And it asks us for the value of the radius r. It says work out the value of r, so it's root 2. Moving on. This one is a bit of a mixture of, well, circles, but also we've got another straight line we've got to plot. So, it says on the grid, draw the graph of x squared plus y squared equals 12.25. Now, centre is 0, 0, and it's equal to 12.25. So I need to square root 12.25 to get my radius. So radius is 3.5. Radius is 3.5. And it's a good idea, I would think, to mark this on. So, a bit hard to see with this graph. 2.2, 2.4, 2.6, 2.8, 3, 3.2, 3.4, so 3.5 is there, and then it's got to go through minus 3.5, so 2.2, 2.4, 2.6, 2.8, 3, 3.2, 3.4, it's halfway, so it's about there, and then 2, it's a bit easier to see going up this way, rather than left or right. And then down. Now what I'll then need is my compass to draw this. There's my compass. Super. So I need to put my point on 3, 0. I think I need to tighten my compass up, but I'll do my best, which is why I put these points on. A good tip with your compass, if you lean it, it's less likely to move the pencil. I'll have to go this way. So if you lean it down like I'm doing there, it's a bit easier to get your turning circle. Just line it up again. Like I say, I need to sort out this compass. It's gone, well, the screw isn't very tight, so if yours is the same, it's just this screw at the top there you need to tighten up. Also, this diagram is really small, so it makes it hard to turn it, which is why it's useful if you lean your compass. Okay, so that's pretty good. I need to tighten this compass up. And then I need to draw, it says on the graph I've drawn this, so part A done. Hence find estimates for the solutions of these simultaneous equations. So 2x plus y equals 1. Now I need to plot this. The easiest way to do that is to rearrange it into the form y equals mx plus c. So, make y the subject, take away 2x from both sides, I get y is equal to negative 2x plus 1. Now to plot this, all I need are 2 points, and then I know it's going to be a straight line because it's in this form y equals mx plus c. I know it goes through plus 1, so it's going to go through here, so it's got to go through there, and then it's going to have a gradient of minus 2, so it's going down. Now, what I could do is plug in basically my smallest number on my x and my largest number on my x to give me 2 coordinates, and then I can draw my straight line. And then where these line and the circle intersect would be my estimate for the solution of this simultaneous equation. Okay, so I'm going to do some working out down here. So y is equal to negative 2. If I use 6, I can find where that coordinate would be. Negative 2 times 6 plus 1, y is equal to negative 12 plus 1 is equal to negative 11. So that's not going to be on there. And basically what I'm doing here is I'm working out for x values and y values, working out what they are. I'm basically filling in a table, but I'm just working out 2 of them rather than all of them. So I can do, let's do negative 6, negative 4, negative 2, 0, 2, 4, 6. So negative 2 times 6 is negative 12, add the 1 is negative 11, so that's negative 11. Then I'm going to do this one, so negative 2 times 4 would be negative 8, add 1 is negative 7, again that's not on the grid. Then we've got negative 2 would be times 2, which is negative 4, add the 1 is negative 3, so I can put that on, so that's 2 goes down to negative 3, which would be here. Excuse me. Okay, and then negative 2, well, if we do 0, that's going to go through at 1, because negative 2 times 0 plus 1 is 1. Negative 2 times negative 2 would be 4, add the 1 is 5. Negative 4 times by negative 2 is 8, add the 1 is 9. Negative 6 times by 2 is, times by negative 2 is 12, add the 1 is 13. You don't have to plot all these points, we can just plot a couple, because we know it's going to be a straight line, it's got to be accurate. If you're unsure, the more points you plot, the better, the more accurate your line is going to be, but generally 2 should be fine as long as you've done them well. So 2 and negative 3, that's good, that's on there, so that is going to be very close to the solution. I've got that one, so I know it's going to be going up like this. Let's go with, can I do negative, I can't do negative 4 and 9, it won't go on the grid. Negative 2 and 5, which is 2, 4, 6, 8, 10. Just check my eyes. Check my eyesight again. I haven't gone wrong. 2, 4, 6, 8, 10. So it's going to go here. So now I put my ruler on. What's a good idea as well is if you put your pen on the points, because sometimes it looks like your ruler is on them, and then you actually do it and it doesn't go through them. Okay. So it's not quite perfect, which is why if you draw more lines it will get a bit better, but this is only finding estimates, so it should be fine. So we've got this point here and this point here, which you need to write down basically what those are. So that's going to be negative 1, negative 1.1, we're looking at where they cross. I'm going to go negative 1.1, so x equals negative 1.1, y is equal to, that's 3.2, 3.3, or x is equal to, I'm going to go with 2, y is equal to this point here, which is negative 2.9. Okay, that's what you need to do for that question. Solving simultaneous equations graphically is basically drawing the graphs and seeing where they intersect. Okay, moving on. The diagram shows a circle centre O. AB is the tangent to the circle at the point A. Angle OBA is 30 degrees. Point B has coordinates 16, 0, so that length there is going to be 16. Point P has coordinates 3P and P. Find the value of P. Give your answers correct to 1 decimal place. Now, if I draw a radius on here, I know from my circle theorems that the radius meets the tangent at 90 degrees. So then what I've got is a right angle triangle here where that length is 16 because it goes to 16, 0. This angle is going to be 60 degrees because it's 180, take 90, take 30. And I can use this, using some trigonometry now, I can work out this bit, this radius. I'll call that R. So I've got, if I use my 30 degrees as my angle I'm working from, I've got the opposite and the hypotenuse, because this 16 is opposite the right angle, so that's the hypotenuse. So I've got opposite and hypotenuse. If you remember SOHCAHTOA, opposite and hypotenuse is sine, so sine 30 is equal to the opposite, which is r, over the hypotenuse, which is 16. So to work r out, times both sides by 16, and we get r is equal to 16 times sine 30 as the exact value. I'm going to keep it like that for the moment, because if I change it into a decimal, I could get a rounding error later on when I'm working out these p's, 3p and p. So I'll draw that radius on now as well. That might help, might not. I don't have any angles here, so I can't be sure of that. But that is, if I went along, I'm going to do it above this triangle because it'll make it a bit easier to see. So that is a distance, x, of 3p, and then this is a height of p. Well, there's probably a couple of ways. No, actually, maybe there's not. The way I'm thinking, because again, we've got this right angle triangle, just upside down at this point. I could have done it here, but then it would have gone a bit confusing with 16. I can use Pythagoras. So, because I know the length of that line is 16 sine 30, and these have both got p's in, so I'll get an equation I can solve. So 3p squared plus p squared square rooted is equal to 16 sine 30. So we get square root of 3p squared. Now you've got to square the 3 and the p, so you get 9p squared, add p squared is equal to 16 sine 30. So that gives us root 10p squared is equal to 16 sine 30. Now I can square root the p squared, but I can't square root the 10, so we end up with root 10 times p is equal to 16 sine 30. So then what we need to do on both sides is divide by root 10, and we will then get, and then I can press ST on the calculator, the exact value. So p is equal to 16 sine 30 over root 10, and then we'll see what that gives us. We want it to one decimal place. You must show what you're working as well. 16 sine 30 and then over square root of 10, and that gives us 4 root 10 over 5, which is 2.5 to one decimal place, and that we don't have any length, so it's just 2.5. Now if you wanted to check that, we could just check that that gives you 16 sine 30. So let's basically plug this into here. So if we have square root of 3 times answer squared plus answer squared, that should give us this value, 16 sine 30. So that gives you 8, which if we work 16 sine 30 out, should also be 8 is. Okay. Now that could be, because sine 30 is one of these values you need to know, could be a non-calculator question. Okay, sine 30. I recommend using a hand trick because I've seen it before. It works quite well. 0, 30, 45, 60, 90. So if it's 0, 30, put the 30 finger down. Now sine is square root fingers above. Sine is square root fingers below. Excuse me, over 2. So that would be square root 1 over 2. So square root 1 is 1. So the sine 30 is a half. So you get 16 times a half, which equals 8, which is why that's 8. Okay, so that could be a non-calculator question, which is a bit horrible to think about. Moving on. Actually, saying that, possibly not. And the reason is, probably not, root 10. You'd end up, unless they said an exact value, which they don't, this couldn't be, because you'd end up at the bottom here with 8 over root 10, which you couldn't work out without a calculator, no, so they couldn't give you this one. But everything else there you could do. If they'd just given that as, I don't know, say they put here, I don't know, a number that you could square and then add it together, and then you'd be able to square root. So say they put this as 3p squared and that as 4p squared, you end up with 9 add 16, then you can square root the 25 to give you 5, then it would end up being 8 over 5, which you can work out as 1.6. So they could have done something like that. Moving on. What I'm going to do, I'm going to leave this question for the moment. It's a great question, but I'm going to leave it because I want to get on to the tangent questions. So, diagram shows a circle, centre, the origin, so OO. The point P has coordinates 8 and -6. Show that point P lies on the circle. We can see the radius is 10. So the equation of this circle is x squared plus y squared is equal to r squared. So that's 100. If point P lies on the circle, we can substitute the coordinates in and it will equal 100. So 8 squared add -6 squared equals 64, add 36, which equals 100. So point P must lie on the circle. Find the equation of the tangent to the circle at point P. Now point P is going to be about 8, -6, it's going to be about here. Now it doesn't actually matter, I'm just showing you this for context so we can think about what's going on here. It doesn't really matter where I put that across, it doesn't have to be accurate. So that's my radius. Now a tangent is a point that just touches the outside of the circle. Okay, so like that. Now the tangent and the radius are perpendicular. So if I work out the gradient of the radius to this point, now that's centre 0, 0. This point is 8, -6. If I work out the gradient there and do the perpendicular gradient, and then substitute in 8, -6, I can get the equation of the tangent. So, I'm going to set this out in hopefully a neat way, which is number 1 for me, to help me think about this properly, number 2 for you, so you can understand it, and you can then do this when you have these types of questions, but also when somebody's marking this, it's clear what you've done. Okay, so it's important you lay it out clearly. So gradient of radius is y take y, so -6 take 0. I don't know why I put that in brackets. Over 8 take 0. -6 take 0 over 8 take 0 gives me -6 over 8, which is the same as -3/4. Okay. Gradient of the tangent, therefore, is the negative reciprocal, is -3/4, that's positive 3/4, then you do the reciprocal, so that's 4/3. So then we get equation of the tangent is, now what I would recommend at this point is using that formula formula I told you about earlier on. Y minus y1 is equal to mx minus x1. Because you just have to substitute in the gradient 4/3 and this point. So y minus -6 equals 4/3 x minus 8, and that's done. Okay, so y minus -6 is +6 is equal to 8 brackets x take away, not 8, 4/3, that's got to be, isn't it? 4/3 x take away 8. Okay, so that's my answer, and I can just leave it as that. So y plus 6 is equal to 4/3 x take away 8. Now if I did want to work it out in terms of y equals mx plus c, so sometimes they might say that, I can just do this and expand it and rearrange it. So I get y plus 6 is equal to 4/3 times x, 4/3 times by minus 8. So that's going to be minus 8 times 4 is 32, so I get 32 over 3, and then minus 6, so minus 32 over 3. Take away 6 from both sides here, and I'm going to get y is equal to 4/3 x. I'll do this on my calculator just for speed. minus 32 over 3 minus 6 minus 50 over 3. So that would be the same equation. Okay, if you don't believe me, plug y equals 1 in and see what the y value is and plug them both in here, you'll get the same thing. Okay, but if you do this, you don't have to work out this minus 50. It should be over 3. You don't have to work that bit out. Okay, the next question is also to do with a tangent. Tangents really, to circles, they're really nothing to do with the circle apart from knowing maybe the equation. That's the only thing. It just looks more complicated. The only thing you have to know is that the tangent is perpendicular to the radius. So you work out the gradient of the radius, negative reciprocal, then it's just the equation of a straight line. Tangent crosses the y-axis at the point 0p, so that is going to be basically what's the y-intercept. Okay, find the value of p. So we find the equation of this tangent, whatever we add or subtract on, if it's in the form y equals mx plus c, will be the point p. So, gradient, again, of radius equals, that's 0, 0, so let's do y take y, 16 take 0, over negative 12 take away 0. So we get 16 over negative 12, divide top and bottom by 4, we're going to get 4 over 3, or negative 4 over 3 I should say, so negative 4 thirds, gradient of tangent is equal to negative reciprocal, which is 3/4, and so then equation of tangent equals, I'm going to do it in the form y equals mx plus c because I need this c this time, so it's actually going to be useful to have it in that format. Y is equal to 3/4 x plus c. Plug in my numbers, so 16 is equal to 3/4 times by negative 12 plus c. So 3/4 times negative 12. 12 divided by 4 is 3, times by the 3 is 9, so I get 16 is equal to negative 9 plus something. Add 9 to both sides, and we get 16 add 9 is 25, so 25 is equal to c. And that's all really we need to know. We just need to p is 25 then, because the equation would then be y is equal to 3/4 x plus 25, and I would just check that actually that number works when you plug it in, and then just double check the gradient as well. So 3/4 times by negative 12 plus 25 should get me 16. It does. And also just think about your gradient. Does it make sense for the question? This gradient is positive, my gradient is positive. Yeah. Okay. So that has to be 25, and it is 0p. Yeah. Super. Right, there are more questions I have got here. They are quite similar. So I'll just leave them on here. What I'll do is I'll quickly show them, and then you can have a go if you want at doing these questions. But we are coming to the end, and I always overrun, so I don't want to overrun again this week. Not too much if I can help it. So, again, an equation of the tangent at the point P. So you work out the gradient of your radius, negative reciprocal gradient, plug in your value, or use y minus y1 equals mx minus x1. Equation of the circle here is 261. So you can find out the length then of your radius by square rooting this. Tangent to the circle is drawn at point A with coordinates p and negative 15. So A has coordinates p, negative 15. It's always very helpful to put information on the diagrams. P is greater than 0. Okay. Find an equation of the tangent. So you've got one coordinate, you've got your radius. What you can do is you know that negative 15, your y coordinate, is on your circle. So negative 15 squared plus x squared. So you solve that, you get x squared plus 225 is equal to 261. Take away your 225 from both sides, and you get 36. Now it says that p is greater than 0, so when you square root you get plus or minus 6, which means that p is equal to positive 6. So that is 6 negative 15. Then it's exactly the same question as this one. That's the only extra step, substituting in and working out the value. Okay, and the next ones, you don't have any diagram, so what you need to do is sketch a diagram. It doesn't have to be perfect by any means, you should just sketch a diagram. Okay, and then this one, again, is very similar, but it's a little bit trickier because you've got surds and fractions and things. And then the last question that I had, apart from the one on the thumbnail, is, this one, where, again, very similar. It intersects at points A and B, so that will be your x-intercept, so that's where y is 0 on your equation, and that's where x is 0 on your equation, so find those 2 points out. Just work out the length of AB. So to work out the length of this, once you've got the equation of that tangent, and once you've worked out what A and B are, you then, this length, square it, add this length, squared it, and then square root it to get your hypotenuse, which is going to be the length AB. And you've got to show it's in the form A root 5, so something times by root 5. It's a trickier question, that one. Okay, this is the question that was from the thumbnail. So a circle has centre 3, 6. I'm going to put it on the diagram somewhere around there. That is 3, 6. It doesn't actually matter. The point 17,4 lies on the circumference of the circle. Okay, again, this could be in completely the wrong position, and this is why it doesn't matter how you draw your circle or your tangent. It literally doesn't matter, because it makes no difference where the tangent is on the circle. It's exactly the same process, so it doesn't matter. That is the point 17,4. Find the equation of the tangent to the circle at A. So, again, we need the gradient of the radius. That's perpendicular. So, gradient of radius equals 4 take, well, actually I'm going to do 6 take away 4, I'm going to do it the other way around. 6 take away 4 over 3 take away 17. That gets me 6 take 4 is 2, 3 take 17 is going to be negative 14, so I end up with negative 1 over 7. Okay, so that's the gradient of the radius. It is going down very slightly, so negative 1 over 7. I think this actually was drawn, yeah, I did draw this on some graphing software, GeoGebra it's called, which is really good if you do want to investigate any kind of graphs. So that means the gradient of tangent, or the tangent, is reciprocal and negative reciprocal. So it's going to be positive, and then 7 over 1, which is 7. So equation of tangent is equal to, or I should put is actually, because I'm going to have equals in this, y minus y1, so y minus 4 is equal to the gradient 7 times by brackets x minus 17. You've got to remember as well to plug in the point it goes through. And that's my answer. That's the equation of the tangent to the circle. Now, if the question says, put it in the form y equals mx plus c, we've got to rearrange it. Okay, so we're going to have y minus 4 is equal to 7 times x, 7 times negative 17, which I'll use my calculator for this, 7 times negative 17, negative 119. Okay, and then we've got to add on the 4 to both sides. Y is equal to 7x minus 115 if I add on 4 to both sides, yeah. And that's the equation of the tangent. Okay, I hope that was all useful. I'm sure, if this is something you were struggling with, it will have been very useful. There's lots of things to remember, but the best thing, like with everything, is practice. So if it's something you need to practice, you could use Maths Genie, although last time I looked, actually there wasn't a lot of questions on circles and tangents, so you might want to go and use Corbett Maths, or GCSE Maths questions is where I've got quite a few of these from, and you can try these and you can look on there and find the answers. So I think these are under tangents to circles. It's under, I think they've got a section for geometry, which will be under there. Okay, thank you for joining, people. Like I say, hopefully it was useful. If you can like the video, that would be, you know, I'd appreciate that. If you're not already subscribed, subscribe, because we do one of these every week. Good luck with the exam next week. You know, keep working hard, and you will do very well, I'm sure. And then, of course, there is that Buy Me a Coffee in the corner, QR code, or in the description if you want to use that to support the channel as well. Okay, right, thank you everybody, and I will see you next time. Bye-bye.